If you wondered what MongoDB database has to do with Berlin and color palettes, follow me in the next 30 minutes and I will share with you how MongoDB and Visual Studio Code helped me to run an experiment and build a side project that requires collecting and analyzing a real-time data. Think about the workflow when you're prototyping with data. How many things should you keep in mind and on your desktop in order to complete a task? You should be aware of your data structure, remember the exact query syntax, control the data transformation flow, and debug the intermediate results. What can quickly become overwhelming? And you just keep opening apps and pages to find the information or run the command, instead of focusing on your query. Some of you are Visual Studio Code users, and probably many of you are developers who want the most frequently used utilities to be embedded in a single workspace. With the MongoDB extension for Visual Studio Code, you can work with MongoDB data directly within your coding environment. Code reusability, handy snippets, syntax highlighting, and configurable extension settings allow you to build applications with MongoDB much easier. My name is Elena, and I work on the MongoDB extension as a developer. And at the same time, I'm an active Visual Studio Code user. So for my side project, I have chosen MongoDB as a database. My Visual Studio Code app has the MongoDB extension installed. And in this session, I would like to share with you my developer and user experience and demonstrate how using the extension improves your processes when it comes to work with MongoDB. My side project is inspired by a brilliant Twitter account called Color of Berlin. The bot behind it features photos of the sky from the Institute of Meteorology of the Free University of Berlin, picks one color, creates HTML canvas with this color, and posts the status update using Twitter API. I live in Berlin and I immediately fell in love with this project. If you have never been in Berlin, you are probably confused. What is the big deal? What are you talking about? Even though sometimes we are lucky and can enjoy the blue sky and sunny weather, unfortunately most of the time the color of the sky seems to be gray or grayish. I was looking at the Color of Berlin Twitter timeline and I could see the data, but I could not really compare values and contrast recent days with much older ones. I scrolled as long as I had patience. I even put some screenshots together, but it didn't give me the complete understanding if I was right and the color of the year in Berlin is gray. So I decided to build a project that fetches tweets from the Color of Berlin Twitter account, saves them to MongoDB database, and by doing this, unleashes the possibility to properly query, analyze, and visualize data in a different manner. But let me show you the extension for a bit to get you comfortable with the main functionality. First of all, you need to connect to a cluster. You can do it from the Save Connections on the sidebar if you have any, from the connection form where you should manually specify the connection options, or using a connection string. That is my favorite way to connect to MongoDB. If you are not familiar with connection strings, they are URIs that start with MongoDB scheme and also may include such components as authentication credentials, host port, and other connection-specific options. What is also great, they are just strings, so you can easily copy-paste them around, store outside the extension, or share with your colleagues. In order to connect to MongoDB using URI, click the Connect button or open Visual Studio Code command palette and start typing MongoDB. Visual Studio Code will list all available commands for the MongoDB extension. Click Connect with Connection String and it will show you the input field where you can enter your URI. As you type, the extension validates the input string and tells you if URI is not valid yet. When it's valid, press Enter and it will connect you to a desirable cluster. Now for the active connection, you can see all available databases and for each database all available collections. Each collection includes such information as documents, schema, and indexes. Schema is the best place to check all existing fields and their types. And in the indexes list, you can find existing indexes for the current collection. If the required index is missing, you can easily create one using the contextual menu that it will open MongoDB Playground template, which includes the information you need to create a new index. To explore your documents, click on any of listed IDs, and the extension will open the chosen document in a JSON format with the syntax highlighted. You can change the document and save it back to MongoDB using the command S shortcut. Check shortcuts in the extension settings. They may vary depending on your operating system. Because it's hard to find a proper document and retrieve you by ID, you can search for a document using a search playground template, and it will return the document based on the provided query. Open the palette again, and this time click Create MongoDB Playground command. It creates a playground with another template. That is basically a placeholder that you can simply delete from the editor, disable from the extension settings, or actually use as an example on how to work with MongoDB. MongoDB playgrounds are JavaScript environments that can execute your code directly within the Visual Studio Code workspace. If you're curious about the technical side, about how playgrounds work under the hood, how they execute users' code, I will get there in the second part of the talk. Switching to my Color Berlin palette project. I will skip the part where I fetch tweets to the MongoDB database. There is just one slide with the Twitter API I used in case you're curious. I want to focus on reading documents from the MongoDB database and transforming them to a new format to answer the question how the color of the sky changes during the week. Previously, I will definitely open Compass to explore my documents and build aggregations. But since I use Visual Studio Code with MongoDB extension installed, I don't need to launch any additional applications. I already have one document open in my workspace, and looking at its values, I can immediately identify the first aggregation stage I want to develop. The created add field stores a string value, but to sort tweets chronologically, I should compare dates instead of strings. I want to keep the created add field unmodified, therefore I'm going to add an additional field to the end of the output object. And I will do it using MongoDB Playgrounds. First of all, you need to specify which database you want to use. Inside string literals and aggregation stages, click the Ctrl+ shortcut to trigger intelligent autocomplete. If you connect it to a cluster, the extension will be able to fetch available databases and suggest their names to autocomplete your statement. When the database is specified, start typing db. And the extension will suggest you a list of available collections for the selected database and a list of MongoDB shell commands for the DB namespace. The same way, you can get the information about available aggregation stages. Select $add field keyword from the list of stages, and the extension will generate a snippet for the stage. Using the generated snippet as an example, I added a new date field to my aggregation output. To run the playground and get the result from MongoDB back, click the play button in the navigation bar at the top right corner of the window. The playground editor splits to the right and prints execution response to a playground result pane. And here it is, a new date field was added to the end of the document as it was expected. The same way we add the rest of aggregation stages: match and rejects to exclude tweets with invalid colors, sort to order tweets chronologically, group because we want to see how color changes during the day, limit to return only 7 days because we are building a weekly statistic, and project to reduce the size of the response because we need only date and color information. Also, you have an ability to run a single line or multiple lines of your playground. MongoDB for Visual Studio Code shows the run selected lines from playground code length immediately above your selection. With this link, you can test and troubleshoot specific stages of your aggregation. Make sure that selected code is valid JavaScript code and you also selected use statement. Otherwise, by default, Playground will run a query against the test database. The extension provides you several ways on how to check the current connection. You can see the current active connection at the first line of your playground, and you can click on this link if you want to change the active connection. You can choose from the list of saved connections or enter a completely new one. Another place where you can check the active connection details is the confirmation model that appears each time when you run the playground. If you find the confirmation model annoying, you can disable it from the extension settings. Speaking about configurations, by default, the playground results pane is displayed at the right-hand side of your workspace, but you can drag and drop it around to organize the workspace the way you prefer. All playground outputs results to the same playground result pane. Otherwise, for multiple playgrounds, it will be hard to find where is the input window and where is corresponding output. So with MongoDB Playgrounds, you can access your MongoDB documents, prototype queries, check playground results, or even run stages to debug your aggregation pipeline. But there is even more that you can do. MongoDB Playgrounds are JavaScript environments. It means you are not limited to write only MongoDB commands. For example, you can use console logs so you don't have to change the playground output each time you want to check the result of some intermediate step. You can simply print the debug information using console logs to the Visual Studio Code output channel. Or you can require the built-in Node.js modules directly inside your playground. Here I use util_inspect method to convert JavaScript object into a string, the same way as I will do it in a regular JavaScript file. And here I use the fs module to log some information to the file. Console logs and loggers are great tools that you can use to debug your playgrounds or keep the history of playground changes. In the generated log file, we can notice something interesting. One part from the aggregation stage is actually missing. The regex value is an empty object, but it should be an expression instead. But why did it happen? It happened because we use JSON stringify method, but the object we were transforming is not JSON object, it is a BSON object. Like JSON, BSON is the list of key value pairs, but it also contains extensions that allow to represent data types that are not part of JSON specification. For example, the regex type. You could require BSON module like this because playgrounds allow you to require not only built-in modules, but any Node.js modules. But we added JSON to globals to make it even easier for you to use. So you can just replace JSON with JSON and it works. Now the MongoDB data is properly stringified. If you normally use some external loggers, for example Pinna, you can also use it inside your playgrounds. This code snippet requires Pinna multi-stream module and allows you to write logs to different files depending on the stream level. Please note that these not built-in node modules you should copy-paste in a specific directory to make them visible for your extension. I have shown you just a couple of examples to demonstrate how many different things you can do with playgrounds, how smart they are and easy to use. The playgrounds are designed to make you feel as more productive as possible, support your workflows, and help you to build complex and reliable applications. If you're happy with your playground, you want to keep it and reuse in the future, you can save it to the current project and it will appear in the MongoDB Playgrounds tree view. The Visual Studio Code interprets all files with the MongoDB extension as playgrounds. So you can create a MongoDB file outside the extension, you can get it from someone else. It doesn't really matter where this file is stored. As long as it has MongoDB extension, you connect it to a proper database with proper access in order to run these commands. And of course, you can copy-paste the aggregation pipeline to your code when it's ready. My project is written in TypeScript, but playgrounds require input to be made in a JavaScript-based query language called MongoDB Shell. Therefore, I can copy only array aggregation stages to my application, but not the full code from the playground. The MongoDB Shell language is very similar to JavaScript language, but they are not exactly the same. In MongoDB Shell, we should specify a database first and then run other commands. And note the aggregation command includes collection name and command is synchronous. The JavaScript code uses the MongoDB Node.js driver to connect to a desirable database and work with data. The driver API is asynchronous, therefore we shall use traditional callbacks, promises, or async await syntax. We fetch a connection object first and then use it to run different collection methods. Keep these differences in mind when you prototype your query, so you can plan these code blocks in advance. In a way, it will be easier to copy-paste them to the aggregation in your project later. Before switching to the technical details of how playgrounds are implemented, let me show you some colorful pictures. This is how our aggregation results can be visualized. The vertical bars represent the color changed during the day, from the morning until the very midnight, and the circles below them represent a dominant color for this particular day. There is a lot of gray, right? And there is another one where each circle represents a tweet. Actually, using this visualization, I was able to notice when weird colors start coming, and I needed to add a regex validation to my aggregation pipeline to prevent crashes of the UI. I started working on this project at the beginning of the year. Therefore, unfortunately, I cannot give you the winner color of the year yet. But I continue collecting the data, so hopefully at the end of the year, I will be able to share the results of my experiment. I bet the winning color will be gray, but maybe I'm wrong. I want to be surprised. We'll see. So playgrounds, how do they work? How did we build them? First of all playgrounds are regular JavaScript Visual Studio Code editors. Therefore, they include features that users expect when they work with source code. Playgrounds are powered by the Visual Studio Code language server. We added it to extension to implement the autocomplete feature, but we also leverage it as a background worker. I will share more details later. The code that users type in their playgrounds is being processed by Babel parser. We build and traverse trees in order to find place where we can suggest you autocomplete options, so you don't have to type long sequences manually or remember the exact query syntax. The last but not least, we use the MongoSH model to evaluate the code from the playground and get the result back from the MongoDB database. MongoSH is a new MongoDB shell that is built to be extensible and embeddable. So in addition to using it in terminal, we can use it as a part of other products, for example, Compass or Visual Studio Code Playgrounds. We take users' code from the Playground editor and send this as a string to MongoSH. MongoSH runs the code and returns some value back. It can be a JSON object, some JavaScript value, or an error that we handle on the extension side. The call to MongoSH happens not in the main UI thread of the extension, but in a background thread created from the language server to ensure that the long-running operations do not block the entire application. We added the language server to the extension in order to support language-specific features that can be very resource-consuming. The autocomplete requires parsing of the user input, building and traversing abstract syntax trees that can significantly increase CPU and memory usage. Because the language server is a separate JSON RPC-enabled process, it provides an option to handle any processing of the main UI thread. Therefore, we leverage it as the background process to prepare autocomplete options and interact with MongoSH. But if the language server is a separate process, why do we need then background threads? Users of the extension can write any possible code in the editor, execution of which can lead to unexpected results. We don't want to force users to reopen the Visual Studio Code workspace each time they accidentally build an infinite loop, like the one on the screen. When user runs the playground, the extension sends a request to the language client. The client adds a cancellation token to the request and transfers it further to the server side. The language server, first of all, constantly listens for cancellation events. And secondly, creates a child thread that becomes responsible for the execution process. The child thread tries to complete the assignment, but if something went wrong and the language server did not receive any values back, it can be terminated as soon as the cancellation request is received. We cannot kill the language server itself. This is why we added the background process on top of it. From the UI perspective, it looks like a progress window with the cancellation button on it that remains visible until the server finishes the assignment or until the user clicks the cancellation button. The MongoDB extension for Visual Studio Code is an open source project, so you can check the repository and further explore how all these parts work together. Visual Studio Code is one of the most popular IDEs these days, and being an active user of Visual Studio Code myself, I'm always excited to see how new extensions complement the core functionality of the editor. With the MongoDB extension, users can connect to local or remote clusters, navigate and modify their MongoDB data, and they don't have to switch between applications anymore. In this talk, I focused on playgrounds because they really shine when it comes to build long and complex scripts and pipelines. I also touched a bit on the implementation specifics like MongoSH and the language server, because it's fascinating to see how these tools power the MongoDB extension and bring playgrounds to life. The playgrounds are a great tool to onboard new developers. The syntax highlighting, autocomplete, debug options, ability to organize your workspace, quick access to documentation, all these features are designed to make you more productive and relaxed at the same time when you prototype with MongoDB. The experienced MongoDB users who work with Shell on a daily basis can just jump in and use Playgrounds to improve their processes without any learning curve, because Playgrounds provide the same functionality as the Shell does. With our extension, you can focus on building your applications with MongoDB instead of searching for tools and applications that can help you with that. The MongoDB extension is one of the most exciting projects I have been working on. Thanks to everyone in the team who make it happen, and thanks to everyone who was watching the session today and who tries the extension. Your feedback helps us to make it better. Thank you very much.